So the definition for mechanical energy is the sum or the total of the potential and kinetic energy in an object. And for something to have mechanical, like both of these things, it would need to be moving to have kinetic energy, and it's going to have to be at some kind of height in order to have GPE. So we've got just a couple brief other ones to talk about, and then we're good to go, right, Dante?
Yep.
Okay. So next one we've got here is thermal energy, which some of you knew at the start, so you may or may not need this depending on where you're at. But thermal energy is the energy that's in the atoms that are moving around when they heat up. The hotter they are, you might remember, the faster they go. And that's how thermometers work. Like, you've got some liquid in there, and when the liquid in there heats up, it takes up a little more room and spreads out and tells you your temperature. But thermal energy is from the random motion of particles. The more energy they have, the faster they go and the hotter it is. The only stuff you need is this underlined portion up at the top here. You don't need all this down below. Dante?
Is it possible to make an atom too hot to the point where they don't ever get together?
I mean, we have another stage. They'd be in plasma, I think. So like solid, liquid, gas, plasma. So beyond that, I'm not confident. So moving on to the next one, if that's all right. Okay, the random motion of atomic particles. Next one we got is chemical energy. And one example of that would be like the forest fires that we had this summer that kind of clogged the whole town with smoke. Energy is stored in those trees that are standing alive, that are standing and dead. It's stored in the energy it's stored in the things that are on the ground, like the debris and stuff that's on the ground. All that has energy inside of it. And it gets released when that fire consumes it. I don't know if you guys have seen any of the spots that fire burned this summer, but it looks like the surface of the moon. Basically, it burned it right down to bare dirt. There's nothing left in a lot of spots. It's just dirt and like little black ashen stumps that are left behind. So chemical energy is energy that's stored in chemical bonds. Electrical energy, the next one we'll do. Say it again. Okay. Electrical energy is the energy of electrical charges, right? Like that's what's powering this right now. That's what you've got stored. That's what's coursing through all the lines in this town. And there's actually a really good career associated with this. If you're not scared of electricity and you're not scared of heights, then being a lineman might be a decent choice for you. Those are the guys that climb the power poles and like get the power going when it's out. They get paid really well. You don't need a college diploma. You can get done with high school. You take like a 4-month course in Idaho or California, and they guarantee you a job, and you're making like $65,000 to $75,000 a year, like a year out of high school. You just got to be willing to live in different parts of the country, but they'll guarantee you a position. And by the time like 4 or 5 years into it, you're making over $100,000 doing this. So if you're not scared of heights and you're not scared of electricity, consider look at the career of a lineman. On what?
Like if you live in like somewhere like where it'd be housing for $1 million,
right.
You make that much money.
Well, you still make that much money. It's just not as useful,
Yeah.
if that makes sense. So we got one more to do, I think, and or 2 more to do. The next one is electromagnetic. And electromagnetic energy is energy that is light. So all that light you see from stars at night or from the sun right now. Riley and Ben, can you guys like refocus, please? And that's 3 times I think I've talked to you guys. Can that just be enough for today? Riley?
Yeah.
Thank you. So we've got electromagnetic energy is really just light, and light travels through space. So all that stars you see at night, that's kind of cool to think about, but you're really looking back in time when you see those things, just like when a firework goes off and like 4 seconds later you hear the boom. Same thing's true for these. These things are so far away that the light that's hitting your eyes, like when you go to look at the stars at night, left those things millions of years ago. So if you had a telescope powerful enough and you could actually see like the planet, you'd be seeing what happened, millions of years ago. You'd be looking back in time. Just like when you hear a firework that went off like way far away from you, you're hearing something that happened a couple seconds ago. When you're seeing these, they're so far away, you're actually seeing something that happened like millions of years ago. Kind of cool. Yeah. Last one, nuclear energy. Right, and this is the stuff that we use to fuel power plants. This is the stuff we use to have that has nuclear. Our nuclear arsenal is based upon. We have nuclear energy. So when you got that, you are done with notes. But nuclear energy is energy stored in the nucleus of atoms.